Question number three. What is the primary rule of the foundation model? FM as in Databricks Generative AI. So in that question, let me analysis about the all the option. Storing structured data. Storing data is not what the foundation model do. This is typically handled by the database. Yes, if you want to store the data. So for that, data lake is the good example. Warehouse is the good example, which store the data, structured data. Here is talking about structured data. So storing structured data, it's a work of data lake or warehouse. Option B, executing Spark jobs. Spark job process large dataset in parallel. So it's mainly used to processing a data set which is in the large level. Why Spark is the part of the Databricks foundation model. Themselves don't execute a Spark job. Spark just help to prepare or feel data in model. Yes, if Spark help to prepare and feed data to model. This is the main task of executing Spark job. Option C, generating context and understanding context from the unstructured data. This is something. This is exactly the foundation of model design for FM, like GPT, LLMA, can interpret text, images, audio, and video, and generate meaningful output like summarize, code, or semantic data. This is something is the main can say main role of the foundation model. Querying data lakes directly. Data lake is stored layer from the structured data. You would use SQL or Spark to query data lake, not foundation model directly. So correct answer is option C. Question number four. A generative AI engineer just deploy an LLM application at the digital marketing company that assists with answering customer service inquiry. Which metrics should they monitor for their customer service LLM application in production? A, number of customer inquiry process per unit. B, energy uses per query. Final reflex score for training of the model. D, Hugging Face leaderboard value for the base LLM. So let analysis about the option. Option A is a number of customer in inquiry process per unit of time. Means this measure throughput how many customer query the application can handle efficiently. In the production, this is a key performance metric to ensure the scalability and responsive. This is relevant because if throughput drop, customer will experience delay. So this is something which we require. Option B, energy uses per query. While energy efficiency is important for the cost and sustainability, it is not primary operational metric for ensuring good customer service performance. This is usually tracked in research or optimization phases, not daily production money. So option B is incorrect. Option C, final perplexity score for the training of the model. Perplexity is the training or evaluation metric that measures how well a model predicts the text, right? However, once a model is already deployed, you do not track the perplexity anymore. You monitor real world performance, not train the model metric and all. So option C is also incorrect. Hugging Face leaderboard value for the base LLM. Leaderboards show the benchmark performance of the base model, like GPT, LLMA, or standardized tasks. So this does not if reflect your production deployment performance, and it would not change just because your application is running. So option A is the perfect answer. Question 5. Which database feature enable efficient versioning and access to training data used in Gen AI models? ML flow, feature store, unit catalog, data lake. So ML flow is used to experiment tracking, modeling, versioning, and deployment. But it's a primarily manage the model and experiment, not for training data itself. But here it's asking to training data used in GenAI model. So option B, feature store. Feature store used to manage, reuse, and service feature for ML model. It does not help to organizing feature data. But here it's asking about the feature data. Feature enable means we have to feature data. It's a more creative and mm, rather than generating training and versioning. Unit catalog in database governance and data management layer. It provides the centralized data access control, lineage, versioning for the data. This aligns directly with the question with efficient versioning and access to training data. So option C is the not fitted here. Delta Lake. Delta Lake is used to store format that support. So unit catalog is directly with the question about, aligned with the question. So efficient versioning and access to training data. So option C is the correct. Option D, Delta Lake. Delta Lake is to store format and support ACID transaction, schema enforcement, time travel for people, while it provides the low-level versioning for the data file. Unit catalog sit on the top of it to provide the governance, access control, and organize it. So option C is the correct answer. The employee profile and project scope are unstructured text. How should a generative AI engineer architect their system? A. Create a tool for finding team members. The employee profile and project scope are unstructured text. How should a generative AI engineer architect their system? A. Create a tool for finding team members. Given project, enable all the project scope into the vector store. Perform a retrieval using the team member profile and find the best team member. So in this question, what is the key requirement? Key requirement is match the availability. Means we have a structured data like project dates versus employee availability. Right. And matched by the relevant profile to project is. Means the employee have a best profile and the scope of the project. So we have unstructured text, need embedded and semantic similarity. Use AI approach, not just keyword matching. A ranking candidate is the best overall fit, not just filter by availability. Right. So filter by the availability is the wrong path. Option one says that the focus on the project scope in the vector store, right? And focus retrieval query is team member profile, which is very wrong around. Why? It ignore availability explicitly. No clean mechanism to filter by this. This is the option A. Create a tool to find the availability team member, the given project. Embedded all the project into the vector store and perform retrieval using the team member profile to find best team member. So in option A, embedding all the project into vector store means the what the project we have that we embedded it and perform the retrieval using the trained numbers. Means how we can retrieve him. This is the wrong way because it's completely ignoring the availability explicitly. So not option. B. Extract keyword with LLM. Right. And do keyword matching again the profile. This keyword extraction rather than the semantic embedding. So keyword matching is the less accurate than the embedding based similarity. So keyword matching is not correct here. No? So option B is also incorrect. Option C, find team members, calculate similarity score, project versus the profile, rank the best score. This is clearly handled by the both the requirements. Filtered by the availability first, structured data, right? And use the similarity score semantic embedded also LLM similarity to match the profile. So rank by score and best available. This is the option C, which is I think correct. Now option D. In this, we are also doing embedding team member into vector store and retrieve the project form. Filter the best available. This is also good approach, but nice it to filtering rather than the ranking, combining scoring. It might work, but filter after retrieval is less resource than the computing or joint similarities now, plus availability as in the C. So C is the good fit.